All right, we are going to continue in section 6.3. Okay, we learned some basics yesterday about our vectors. Now we are going to continue with our vectors. We don't know what our notes went. Okay. We have been able to get a vector and find its magnitude and direction. What if we know the magnitude and direction? Can we write the vector? Does anyone see my note sheet? Okay. So how might we be able to write this vector? So let's say we want vector AB. Okay. If this is vector AB, then we go over A and up B. Correct? I am going to give you the direction and the magnitude. How could we find the horizontal component if we know theta and the magnitude? Yes, SOHCAHTOA. Okay, so let's talk about the horizontal component first. A. What trig function would be helpful here? Cosine. The cosine of theta would be A over the magnitude, correct? So if I want A, how would I solve for A? We would have to multiply that magnitude over, right? How might we find B? The sine of theta is B over the magnitude. And to solve for B, we can just multiply that magnitude over, correct? All right. So if you know your magnitude and direction for your horizontal component, written up here as A, we take the magnitude times the cosine of our direction angle. To find the vertical component, up here it's represented as a B, we're going to take the magnitude times the sine of our direction angle. Okay. Here I have that written in component form. Here I have it written in linear combination form. You can either draw a triangle if you want, or you can memorize magnitude times cosine, magnitude times sine. That's how we got that set up, is by drawing a right triangle. Okay, ready for some examples? I suppose you have a choice whether you want to do this. Okay. First example. Here is a vector with a magnitude of 2 and a direction of 45 degrees. That's a nice angle, isn't it? Yes. That is a special angle, which means I expect you to not have to use your calculator. Okay? So let's talk about our component form. All right? Our horizontal component, how do we find it? We would have to say 2 cosine of 45 degrees, right? Our vertical component we take by multiplying to sine of the angle. Okay? Since this is a special angle, we are going to evaluate without a calculator. What is the cosine of 45? Radical 2 over 2. What is the sine of 45? Radical 2 over 2. So, we have a vector radical 2, radical 2. It is in the direction of 45 degrees, and it has magnitude of 2. Not so bad, right? Okay, let's tweak our problem a little bit. Now, I want a vector with magnitude v in the direction of negative 3i plus 4j. Okay, so they didn't give us the specific direction. Okay, they didn't give us a direction angle, but they gave us a vector that they want it to be in the same direction as. So what should we do with that? Okay, what do we need from this? We need the angle from this, don't we? We need the angle from negative 3i plus 4j, so we know what direction v is in. Okay? So somebody said draw it. That would be good. Here is negative 3i plus 4j. Here is the angle that we need to find. So we're going to have to use a reference angle, right? How do we find this angle? Okay, tangent of our reference angle needs to be equal to 4 over 3. So when you take the inverse tangent of 4 over 3, what do you get? 53.13. Okay. We're just going to keep it as a positive. We won't worry about the negative right now since it's a reference angle. All right, so what does that mean about our direction angle? What is the direction angle of negative 3i plus 4j? Okay, 126.87. Okay. Yeah. All right. Since we're in the second quadrant, we need an obtuse angle, so we took 180 minus our reference angle. Here is the direction of negative 3i plus 4j. So now we have our magnitude and we have our direction. So to find our vector v, we can take the magnitude times the cosine of 126.87, and we can take 3 times the sine of 126.87. Okay, anybody have something for me? Well, our x component, or horizontal component should be negative, right? Negative 1.8. And then
change it to be
oh, that'd probably be a good idea. Since we are given that vector in the in linear combination form, we can write this negative 1.8i plus 2.4j. All right. Is there another way we could have done this? Probably. I can't remember. Your book might have these as fractions. Okay, so when you're checking your answers in the back of the book, they may have written this as like negative 9/5 and 12/5. If that happens, then just find that decimal approximation in your calculator and make sure yours would be the same. Okay? I'm fine with decimals though. Alright? Okay, let's talk about this. Here I have u and v, and I have given you the magnitude and direction of each, but I want the sum of u and v. In what order do I find the sum of u and v? Okay, Sarah's suggesting that we find the component form of u, find the component form of v, and then add them together. Do you like that order? Okay, that would be the correct order. We cannot add the magnitude and add the angles. That would be nice, wouldn't it? Okay, but that's not how it's going to work. We need to find the components separately and then add them together. So let's work on vector u. Okay, vector u would be magnitude times the cosine of theta, magnitude times the sine of theta. What is vector u? What's the cosine of 60 degrees? 1/2. Okay? I was waiting for one person. Okay? You guys still need to know the unit circle. Okay? So 1/2 times 4 is 2. 4 times the sine of 60. What's the sine of 60? Radical 3 over 2 times 4 would be 2 radical 3. All right? Now we need vector v. Vector v. So we're going to have magnitude times the cosine of theta. Then magnitude times the sine of theta. What's the cosine of 90? What's the sine of 90? 1. So 1 times 5 is 5. So what we have, u plus v, we have 2 radical 3 plus 0.5. So we would write this as 2 is our horizontal component. Our vertical component, yes, we would have to write it as 5 plus 2 radical 3. Because we cannot combine that radical with an integer. Okay, here's where we get to talk about a little bit of physics. Okay, those of you in physics or who have taken physics, what did you use vectors for? Velocity. What else? forces. Okay. When we talk about vectors, we use them a lot with force, okay, and velocity. I guess we will see both of those. All right. So we're going to do a couple examples dealing with physics, okay? Now, I will warn you, some of the word problems are kind of cheesy, but that's just kind of a part of math class, right? Okay. So, this one's not too bad. Forces with magnitudes of 2,000 newtons and 900 newtons act on a machine part at angles of 30 degrees and negative 45 degrees, respectively, with the x-axis. Find the direction and magnitude of the resultant of these forces. Okay, so first of all, we have two forces. Okay, the amount of force that is being applied to our machine part, okay, that is what we consider the magnitude of our vector. How much force is being exerted, that is the magnitude, okay? And then it's given us at the angle in which these forces are being applied. That's our direction. Okay, so let's kind of sort this out. Let's talk about vector u, okay? Vector u, we're going to say, has a force of 2,000 newtons. So that means the magnitude of u is 2,000 newtons. Okay? What is the angle? What is the direction of u? Okay. Since we listed 200 newtons first, 30 degrees is the first angle, so theta for vector u is 30 degrees. Okay? And then we'll call vector v the second force, okay, has a magnitude of 900 newtons, and the direction angle for v would be the negative 45 degrees. Okay. These two forces are acting on a machine part. We want to know the resultant of these forces. What are they asking for? The sum. They're asking for the sum. These forces are acting together. What do we get? What kind of force do we get when we add them together? Okay? So we need u plus v. First, we better find u and v, right? So here we go. Vector u. We find vector u by taking magnitude times the cosine of 30, and then magnitude times the sine of 30. Okay, so vector u, what's 2,000? What's the cosine of 30? Radical 3 over 2 times 2,000. 1,000 times radical 3. Okay. And then 2,000 times the sine of 30. What's the sine of 30? 1/2. Okay. Let's talk about vector v. Vector v. So we have 900 times the cosine of negative 45 degrees. And then 900 times the sine of negative 45. What is the cosine of negative 45? A positive radical 2 over 2. Multiplied to 900 would be 450 radical 2. Okay. What about the sine of negative 45? Negative radical 2 over 2. Okay. Multiplied to 900 would be negative 450 radical 2. Okay. So when we take u plus v, right, we're going to get 1000 radical 3 plus 450 radical 2 and 1000 minus 450 radical 2. Okay, I'm talking about the force of a machine part. In a real life application, are we going to leave this in radicals? Probably not. Okay, so what I'm going to do, what I'd like to do here is get out your calculators, please. All right, so our horizontal component was 1000 radical 3, right? Plus 450 radical 2. Am I remembering that correctly? I guess a no is a no, right? Okay, so our vertical component, horizontal component, is 2368.45. Now what I'm going to do, remember I showed you this? What I'm going to do is I'm going to say I want to store that in A, because we're going to have to use it later. Okay. Then our vertical component was 1000 minus 450 radical 2, which is 363.6, right? .60. And what I'm going to do is I'm going to store that in alpha B. All right, why did I do that? Okay, if we go back up to the problem, we actually are asked to find the direction and the magnitude of the resulting forces. Okay, so let's talk about the magnitude of these forces. How do we find the magnitude of U plus V? We take the square root of A squared plus B squared, correct? To find the magnitude of our resulting force, we're going to take the square root of A squared plus B squared. Instead of having to retype all of those numbers in, we can go to our calculator and say the square root of A squared, there, plus B squared. So 2000, okay, what was the answer? And what should our label be? Newtons, very good. All right. Okay, now we need to find the direction angle, correct? All right, how do we do that? First of all, what quadrant are we in?
The first.
We're in the first quadrant, that's good, right? Okay, that means we went over 236.845 and up 363.6, right? So to find our angle, we're going to say the tangent of our angle is B over A, correct? Instead of having to write all of that down again or retype it in, okay, we can just go to our calculator and say inverse tangent of B divided by A. And we get 8.73 degrees. Okay, now you don't have to use the store feature if you don't want to. I'm trying to make your lives easier by saving you having to write down and retype a whole bunch of numbers. Okay, if you don't use it, fine, but I'm trying to help you out here. Okay, now we might not have time to completely do this example, but I just want to talk about it. Okay, we talked about our vectors can represent forces. They can also represent velocities. Okay, so here I have an example of a gun being fired. The bullet is traveling, or the muzzle has a velocity of 1,200 feet per second, and it's fired at a 6-degree angle with the horizontal. Find the horizontal and vertical components. Okay, so we're still going to do magnitude times cosine theta, magnitude times sine theta. What does 1,200 feet per second represent in our vector? That is the magnitude. So if our gun is firing at a 6-degree angle, 1,200 feet per second, that is the magnitude of our vector. So you will see your magnitudes given as forces or as velocities in your homework. Okay. Here is your homework assignment. Okay. Not very many problems, is it? No. Okay. You will probably get a good chunk of word problems. Okay. Do not avoid them. Attempt all of them, please. Make sure you draw pictures for all of your word problems. Not all of them are word problems.